there are several ways to look at grounds. The easiest way for an amateur to look at grounding is there are two reasons that we have grounds. They are for safety and they are for increased performance, especially true with certain antennas. This is especially true with the lower bands where most of our antenna selections require us to have extensive grounds. So let's get into it. First of all, we're going to talk about house wiring. If you look at your dryer or you look at your stove and you've got a newer home, you're going to see 4 wires. You're going to see a neutral and a ground. You're going to see the red and the black. Those are hot. The white is the neutral. And then the green is the ground. Ground and neutral used to be considered pretty much the same thing. If you go to an older house, you'll see white, black, and green on a if you pull the cover off a 230 volt outlet. You'll see, 2 hots and a green, which was a neutral and a safety. But with modern appliances, a lot of times what's happening there is you have a 240 volt circuit and a 110 volt circuit or 120 circuit. Like for instance, the heating element in the dryer may be 240, but the motor and the timer circuitry is all 110. Here's what happens. That means you have different loads on the 2 legs. That means that you're neutral, that what is quote unquote neutral there may not be 0 volts. So it may not be grounded. So the National Electrical Code now has 4 conductor wiring. This is going to be important in a little while as we keep talking. So they're not the same. One is a system ground. That's your white neutral. The other is a safety ground. That's your green ground. That is designed to bleed off current and voltage because it don't take a lot of either to kill you, especially if it goes through your heart muscle. 20, 30 milliamps will do it. So the voltages may not be the same for the reason I just talked about. So we keep going and we see what I was talking about. If you look, you see the 4 conductor plugs at the top. Then you see the 3 conductor. Now, since a lot of the times you have 4 conductors, but you may have an older dryer, you see how you have to wire the 3 conductor plug. Instead you don't have, you just have green, red, and black. It would be better if you just wired everything 4 wires if you can, if it's newer. But if you have questions about this kind of wiring, don't guess. This is something you hire. You hire it out, hire an electrician. They're worth the money if they keep your house from burning down. All right, ground rods. I'm going to go back to the National Electrical Code. We're still talking about safety. We're talking about grounds that pull power surges. We're talking about grounds whose job is to handle anything that's floating, like an appliance that has a current on it that you're not expecting, designed to pull it to ground and give you a measure of safety. Ground rods. Right now, the way the code's written, you got to have 2 8-foot ground rods, and they have to be a minimum of 6 feet apart, unless you can prove that one ground rod by itself has less than 25 ohms of resistance. The ground resistance is less than 25 ohms. Do you know what the electricians are doing? They're just putting in that second ground rod because they get paid to do it. So, however, if you really want this kind of thing to be most effective, you need to separate these by twice the length of the rod. So if you can, if you're getting new construction done, have 2 ground rods installed about 20 feet apart for the best results. There's the code right there. 20 feet apart or so, and you're in good shape. Now, the other thing you can do with your house wiring to help ground for safety purposes, power surges, lightning comes in over the lightning comes in through your utilities, is MOVs. And the MOVs are usually installed in your main box. You can also have MOVs installed in individual appliances. You can have MOVs installed in your power supplies in the shack, all that stuff. They're fairly inexpensive, even with the installation, and they're going to protect you from minor power surges. They will not protect you from lightning hitting your drop down right outside. They're not designed to do that. They're designed though to handle that power surge from lightning hitting around, down the street or an indirect hit. Again, fairly inexpensive way, give you some protection. But the best protection for a power surge for your equipment is the ARRL equipment replacement insurance policy, because we are talking Florida. It's not a matter of if, it's a matter of when you're going to get a power surge. It's just going to happen. Your MOVs can protect you somewhat, but if you get a direct hit close by, or you get a really powerful power surge, you're going to lose stuff. And it's for a reasonable cost of money, you can be able to get that replaced. The deductible's only $50. The club has this policy, and just last month we had to use it. We lost a UPS to a power surge. I was there when it happened. It went pop. I heard a pop. I saw that the flex system was no longer operating. Moo and I did stuff to get the system up and running, just to check to make sure that it was only the UPS that it had blown. Once we determined that, we shut the system down. We ordered a UPS. Biff has turned in a thing for replacement of the system. It'll cost us $50 instead of $250. Fairly reasonable. Lightning protection. Well, maybe not that kind of lightning. That kind. So you can get a feel for lightning. Lightning simply occurs when you have a bunch of charged particles that have such a voltage potential between them and the earth that there's actually ionizes the air to go all the way down to the ground. It can be millions of volts and or millions of amps. You do not want to be standing right there when it happens. That's why that's important. All the stuff we talked about, MOVs, ground rods, neutral wiring, stuff like that is also important for lightning. Lightning protection by AC Delco. You're probably going, what the hell is he talking about? In the old days, when we had twin leads, and what you had was a doublet antenna, where you had basically what looks like a dipole, but instead of balun and coaxial cable, you had twin lead. The way you did your ground protection is you got a couple of AC Delco or Champion or Bosch or whatever spark plugs. You mounted them on a piece of metal. You hooked a piece of metal to your ground rod. This is not the house ground rod, but a ground rod you drove to protect your equipment. And then you hook up at the top where you normally would hook the plug wire from the electronic ignition. You would hook the twin lead through there. So I'll show you what it looks like. And that's what a lightning protection for a doublet used to look like. By the way, if you got an end-fed antenna, one of those end-fed halfways, this will work. You just use one. You only need one spark plug. You got a random wire, this will work. This will work, and it'll work well. The other type of lightning protection we see is gas discharge tubes. And as you can see we got a polyphaser and an alpha delta and Pasternak, and a whole bunch of people make these gas discharge lightning arresters. And basically the idea is that when there's a certain voltage differential between the ground and your center conductor. Hold on just a sec. I got a train going by. Later train. When you have a certain electric potential, a certain voltage between the two, the gas in the discharge tube ionizes, shorts it to your ground rod, shorts it to your ground, and it passes through the ionized gas. Now, when this happens, you got to replace the discharge tube. If you look at that alpha delta model in the center, you're going to see where that brass cap is. That is the gas discharge tube, and it's a cartridge. So all you got to do is screw that off, pull the cartridge out, put a new one in. You're good to go. You don't have to cut any cable. You don't have to solder any connectors back on or anything like that. That's how these are built. The one at the bottom, it looks like it has something similar, except then rather than a thumb nut, it's got a nut that you have to use a wrench to get off. That's how they work. I'm not sure about the polyphasers, but I believe some of those are designed that you just pull it out and replace it. I think others you can replace the cartridge inside. Like I said, voltage exceeds the rating, gas ionizes, discharges to surge to ground. This is not perfect. Neither is the AC Delco spark plug. It's not perfect. There's still going to be voltage on that line until it discharges. But it can prevent things from getting worse. You might lose some gear, but you won't lose all of it. If you got a real top vertical, let's say you called up DX Engineering and said, I want that 65-foot metal vertical antenna because I want to operate 80 meters. Or I'm going to take a bunch of helium balloons, and I'm going to take a thin wire and get it as high up as I can because I'm going to run 160 meters on FT8 with a balloon antenna. There you have a different way of discharging stuff, and that is to use resistors to ground. You know, as you can see, this one's 1.0 and then a whole bunch. That's a 10 meg ohm resistor there. So you want to use at least 10 meg ohms, preferably 20, 30, 40, 50 meg ohms. The idea is to provide a very high resistance path to keep static discharge that's going to be on this wire from getting in your gear. It's a little different than lightning protection. This is more to prevent static that builds up slowly on the antenna. Can you do this while transmitting? Yes, because to the transmitter and to your antenna tuner, you say, well, wait a minute, it sees that resistance in parallel with the 50 ohms. Well, if you do a little bit of math, you'll find out if you take 10 meg ohms in parallel with 50 ohms, the resistance is about 49.99. So I don't think your antenna tuner is going to be bothered by that. Not only that, you can put 100 watts across that resistor and nothing's going to happen because the overwhelming amount of voltage, power, current is going to go into your antenna and not in through this resistor. So that's something you can do if you have a real high vertical and you're plagued by discharge, and you'll hear it because it'll be these popping sounds. Sometimes you'll hear it if you have a mobile HF station, you know, and especially if you have a whip antenna, you'll hear these. That's why they have the balls on the whip antenna to try to prevent this corona discharge. So, best protection from lightning, ARRL equipment replacement insurance policy. I mean, you know, I hope nobody expected a different answer from earlier. The fact is, you're going to have the risk of damage at any time from lightning because it's Florida. Florida is a lightning capital. So now we're going to get into grounding for performance. And what does that mean? What that means is that instead of grounding to protect gear or to protect gear and to protect you, we're talking about grounding for the purposes of making your antenna work better, or in many cases, just flat work at all. So do you need a ground for better antenna performance? The answer is not always. Depends. If the antenna provides both halves of the radiating element and a counterpoise type element, you know, in other words, an element that acts in opposition to the radiating element, you know, that monopole that they talk about in antenna ratings. You have to have something that goes to that goes to act as a contrast to it, as a counterpoise. Do you need one? Well, not all the time, but sometimes you do. Dipole? Well, let's see. 1/4 wavelength we've got is radiating, and 1/4 wavelength acts as a balance to that radiating element. So, no. Windom? No and yes. With a Windom, both sides radiate, and they radiate differently depending upon the band. So you really don't have to have a ground system to make a Windom work. Does it help in some cases on the lower bands? Yeah, but is it necessary? No. Off-center dipoles, by the way, behave pretty much the same way. The idea is all you're doing when you move something off-center is you're changing the resistance at the point of the antenna. You're increasing it. An in-fed antenna, by the way, it's a dipole, but by being fed at the end, you've moved the resistance from about 70 ohms, not 50, it's really 70 ohms, to a very, very high resistance. That's why you have to have the box with the 7-to-1 or 8-to-1, 8-to-1 windings, 49 or 64-to-1 impedance transformation. That's what an in-fed does. Vertical dipoles don't need a performance ground. They do need a safety ground. But if you look at a gap antenna, the gap antennas are designed to provide that counterpoise element to it. Now, some of them say that you have to have these these wires sticking out from it. Those are part of the counterpoise element, but it's designed in there so that you don't have to lay down a bunch of radials or anything. Disc cone, same way. If you look at a disc cone antenna, you'll have a radiating element, and then you have all these other impedance matching elements. They basically act as the other side of the antenna. J-pole, it has a stub that does this. So you have both halves of the antenna. You have a radiating element, and then you have an element that acts as a it acts kind of as a RF, not so much as an RF ground, but as an RF counterpoise. Vertical antennas, it depends. Groundplane vertical, kind of like a disc cone. You have the welding rod. This looks like it'd be a 70-centimeter ground plane. Got a welding rod, got a couple other welding rods. That provides a couple of counterpoise elements. The elements that are cocked off at a 45-degree angle are counterpoise. You do not have to have a ground to increase your RF performance. You do have to have a safety ground on these. Radiating element counterpoise system. But what happens when we start talking about that 65-foot aluminum vertical from DX Engineering, or you bought one of those 43-foot fiberglass antennas that have a wire running down the middle of them, and you hook an unnon at the base, or you put an ICOM AH4 at the base. You got to have a ground system to act as for RF performance. Let's talk about that. Radials. Radials basically piece of wire. If it's in the air, it's counterpoise. If it's on the ground, it's a radial. If it's in the air, it should be a quarter wavelength long at the frequency of interest. Can you fold them? Yes. Will it need to be longer if you fold it? Probably. Will it have the same impedance as a straight radial? No, it'll probably be lower, but you can fold radials. In fact, there are some systems for that on 160. But let's say you go, hey, I'm going to just put up one of these 43-foot verticals, and I need to know how to do this. Well, radials. 16 is a really good number for a permanent ground, for a permanent mounting. You're going to mount this, so you mount 16 radials. By the way, these 16 radials are for RF purposes only. These are not for safety. You still want a ground rod with this that will then attach to a gas discharge lightning protector. You know, and ideally you would want this to be either right out at the antenna, or you would want it to be before it comes into the house. All this needs to be outside. 16 is a good start. They don't need to be straight. You can bend them. They don't need to be the same length. You would ideally like some of them to be at least the at least 0.2 wavelengths on the lowest frequency of interest. So if you're going to use that 43-foot vertical and 40, then you want 28, 29 feet to be the length for the radials. I want to point out something now. If you're using certain types of antenna tuners, automatic tuners, they get really squirrely if the radials are longer than the radiating element. So let's say you have an SGC tuner you're going to put out there. Then even if you're going to go on 80, keep the longest radial below 43 feet because you're having a 43-foot antenna. If you got the 65-foot antenna from DX Engineering, well, you'd put 55, 58-foot radials, and you're good. Let's say you can't put 16 out there. Well, then put 8 out there. Put 4 out there, and put some shorter ones in there. It will work. The idea is to build a low resistance ground path for RF, not for static discharge. That's your ground rod. That's your gas discharge cartridge. So, but if you just want to pound some 40-meter CW at the park, with that 43-foot vertical, you bought the one that you can collapse and tote in a bag in 5 minutes. All right, no problem. Slap that radio up, slap it up, slap 4 radials down, and you're good to go. Shorter radials are fine. The idea is that the more copper, the more wire you get on the ground will help you. Let's say you don't really want to bury a whole boatload of wire. You know, you're like, oh, I don't want to buy a ditch witch or borrow a ditch witch and cut my yard up and make it look like we're playing chess or operation out there. Very simple. Cut your grass real short, not short enough that you're going to burn it or anything, but cut it short. Lay the wire out, you tamp it along the ground as you go. Then take some of these lawn staples, staple it to the ground. Take your mower, move the height up on the mower a little bit, so that way when you cut the next time, you don't accidentally catch your wire. And what happens over a few months, especially in the summer, those radials will be eaten by your lawn. They'll pass into the ground and continue to work. So what do you need to be safe? Coaxial fed antenna, you need to have a lightning protection device. It can be a gas discharge device. It can be a spark gap device, which is really what the spark plug is. But it needs to be mounted outside the house. Do not mount this inside. Otherwise, what happens is that discharge is coming in the house. And it's going to make things mighty interesting for you. It should be attached to its own ground rod. Do not use the ground rod used by your electrical system. First of all, it violates the code. Second of all, it's just a bad idea, because then what happens is you run the risk of this discharge going to ground, but then a little bit of it leaking up into all your electrical circuits in the house. I think we can all see why that'd be a bad idea. So that's where coax fit. Let's say you got the vertical. You got a vertical, got an unun, you say, well, how do I hook this up? You take the vertical, hook the unun to it. The center connection from the unun goes to the base of the vertical. All your radials would go to a ground rod at the base of the vertical, hook it all up. Then the radials would hook to then the radials and ground rod would hook to the coax to the outside, and would also hook to the lightning arrestor. That way it'll carry it. That way as much of the surge as possible will go straight down the antenna through the lightning arrestor and go into the ground there outside, away from your house. Now, is that vertical still going to be intact? Probably not. You might find a few pieces left, but if it's hit by lightning directly, it's going to be vaporized, and all you're going to do is find a little bit of burn evidence out there, and you'll be replacing it. That's when you start filling out the form to the ARRL insurance program, pay, and get your money minus $50 back. If you have a doublet, you saw how to do that with 2 spark plugs. Do all this outside. Try to keep the distance from the lightning arrestor, whether it be a spark plug type or whether it be a gas discharge type. Try to keep that as short as is possible. Keep it short, keep it sweet, keep it simple, and make it short as possible. Use the largest gauge wire that you can. Why? If you look at wire, you realize real quickly that if you're using 3/0 welding wire, that really big, thick stuff, you'll realize very quickly that it has a much lower resistance per foot than 10 gauge copper wire. I recommend that you not use aluminum wire. It has a slightly higher internal resistance, and when it does vaporize, it's toxic. It's toxic to your nervous system. So go with copper. Anything else? Yes. Now we got to talk about your radio in your shack. You got to be able to disconnect your radios from your antenna system. You got to be, and in fact, that should be just a way of life. That when you're done operating, disconnect your radios. And the easiest way to do that is with a feed-through panel, which I've got one right here. This one's made by MFJ. You can make your own. And basically the idea is that you don't want a lightning surge which destroys your vertical that's maybe $100. You don't want it to destroy your $2,000 radio, to destroy your $1,000 laptop, to destroy even the drywall or concrete in your room, which is another thing. If you notice these feed-throughs, and all that, when you disconnect, there isn't something hanging down. You don't want a coaxial cable hanging down in your room. I recently heard a story of somebody who let that happen, and he ended up paying a lot of money to have that room remodeled after lightning went through the cable. So we don't want to do that. Lightning's capable of spalling concrete. It can start fires. It's just nasty. You don't want it in the house. If your shack is on an upper floor, you've got a different issue. You may have the aforementioned issues with lightning because you have outdoor antennas, but you also are kind of far away from your RF ground. You may have RFI. there are several things you can do to deal with that. The first one is to spend some time investigating the source and find out. It may be that you have RFI because your power leads are just the right length to act as a radiating element on 10 meters. And so the microphone bites you on 10 meters. Well, put some toroids, in the power leads, or toroids in the audio leads if it's your speaker. You may, in some cases, like I used to have, you may need to have an artificial antenna, an artificial counterpoise. And all an artificial counterpoise is, if you look at the controls, it looks just like a manual antenna tuner, and that's because it is. And that can act as a tuned circuit to help you remove RFI. I'll show you one. This one's made by MFJ. By the way, I own one of these because I used to run indoor antennas. I had a loop of wire on the ceiling of my bedroom and several counterpoise wires on the baseboard. And if I wanted to work 80 meters, I had that artificial ground. And by the way, you can work DXCC with indoor antennas and low power. I did it with that exact circuit I just described. It was basically a matter of just, let the auto tuner tune the radiating element, and then on the low bands, just I had it set up where I knew where to turn each knob, where I learned where to turn each knob. So we made it real simple for indoor operations. So you have a different problem. This RFI tends to be the bigger problem. Still got safety issues if the antenna's outside. Last bit of advice. You will see some older manuals, including the ARRL operating manual, will advise you to connect your ground from your radio to the little center screw in a outlet if you don't have an RF ground handy outside. I'm going to advise against it. And the reason being has more to do with the fact that houses are getting more and more modern. The modern, one of the modern features of houses is ground fault circuit interruption or residual current devices that will trip if they sense RF on them. They'll trip if they sense current on them. And the RF current may be enough in some cases to trip these devices. The older ones are really sensitive to it, and I've actually seen it happen. So you're better off if it's an RFI problem, instead of trying to take the cheap and easy way out, do some investigation, figure out what it is that's causing your RF in the shack, and deal with it, whether it be to wrap a few turns around a big giant toroid for your power leads, whether it's that you need to attach you need to attach a bunch of snap-on toroids on a speaker wire or something like that. Do that. So I'm gonna, at this point, there will be some time for questions. This is a little shorter than 45 minutes. I want to talk though about portable operation and grounding. I mentioned that if you're going to go pound some 40 meter CW or 20 meter CW, or you're going to go do some 15 meter FT8 from the park, that all you need is just a few radials. But I didn't really discuss a safety ground. The assumption that will be made here is that because it's portable and because you should be paying attention to the weather, you don't need a safety ground if the moment you have the first inkling of bad weather, that you immediately disconnect everything, pull the antenna down, and head for your car. If you're one of these people that says, hell, I'll just go to my car, pull the rig, go to my car and leave all the other stuff there, and then I'll come back after it stops lightning and raining and I'll operate some more, then you might want to consider a safety ground. However, in a park, that's going to be kind of different and it's going to be very difficult. But you might be able to actually use a chain link fence. And so, if you can get a good, so you might carry a big set of croc clamps or something like alligator clamps, battery cable clamps to clamp onto a couple of the poles on a chain link fence to act as an ersatz safety ground. And then you would use, again, a gas discharge conductor. We're supposed to be amateurs. That means we're supposed to have a little bit of the MacGyver in us, and we should be able to think through some of this stuff. The fact is, safety grounds are critical. They're what keeps us from becoming silent keys in many cases. The performance grounds are also critical because they keep us from, they make us effective at operating because our systems work better. Let's go back to 80 meters. With an 80 meter system, ideally you'd want 16, 24, 32 radials. But if you don't have it, you don't have it. And you say, well, why would I use radials over counterpoises? So we're going to go back to counterpoise. The counterpoise, being above ground, acts as an ersatz radiating element. There is radiation from it, so it's a little different. So if you're going to do counterpoises, cut a couple of counterpoises a quarter wavelength. If you're going to do a counterpoise if you're going to do this though, you need to have enough height so that humans and animals don't get clotheslined by it. Apparently, up north, some of the 160 operators that have beverages and have counterpoises for their 160 and 80 meter, they have to get them like 12 feet up in the air because it's not humans they end up having trouble with. It's deer getting their antlers hooked in them and yanking them down. So let's be clever. Let's be safe. If you have questions about house wiring, talk to an electrician. Talk to an electrician. We do have people in the club that have this kind of knowledge and they can help you. For RF grounds, I'll answer questions. I know we have some other people in the club that understand grounding from a performance standpoint. We can help you make your systems more efficient and to help you actually, in some cases, decide what the best antenna for a given situation is based on what you can do ground wise versus what you can do putting metal in the air. All right, I'm going to open the floor up.
Okay, Lee, if you got questions for Lee, you will need to unmute yourself and ask away.
Hey, Lee.
Brian, what's going on, brother?
Well, I missed half the presentation audio because somehow it got disconnected on my number one computer. So I switched to number two computer. And so how can I replay this?
Brian, we are recording it and we are recording this, so it will be available on the website here in a few days.
Meaning that I go to the website and it's intuitive or it's self-evident how I can find it?
If you go to the website, there is a tab called TARCTalks. All our TARCTalks have been recorded and you can find it there. It will take us a few days to get it up there, but once it's there, you'll be able to listen to it.
Oh, great. Yeah.
So you missed the part where we were giving away free beer.
I darn it. I'm always missing out.
All right. Any other questions? Something for Brian.
Yeah, Lee.
No, that's all for Brian.
Okay.
Hey, Glenn, what's up?
Not much. I had a question about the two spark plugs for protection. Now, would that have to be in an enclosure if we were getting like heavy rain and those things were exposed to the rain? Would it make any difference if they were getting soaked? Say the rain was dripping on them.
It would be advisable to have them in an enclosure, but I would also point out that if you're operating in a heavy rainstorm in Florida, that you're asking for trouble, because you can expect there to be lightning with rain in Florida. So at that point, I would hope that you would just disconnect everything from your radio and go read a book or something, because you do not want to be operating during a rainstorm.
Well, that's what I figured. It was just a general question, just to.
No, it's a good question. You can do that, and some people do. Another thing that some people do to protect lightning arresters like that is they'll take a paint bucket and they'll put the bucket over the arrestor to act as a protection against rain, but at the end, but without enclosing it to the point where you might get critters in there or water entrapped in there the whole time.
Okay, well, hey, thanks for the info, and you're doing a good job, and I appreciate all this information. Really do. Thank you.
All right, not a problem.
Frank, you had a question?
Yeah, I just wanted to make sure if I was understanding correctly, where you were talking about grounding, and if you come in, have to a lightning arrestor and have that grounded to its own ground, not the electric system ground. But I've read in places where that ground and the house electric system ground should be wired up together. Am I misunderstanding what you were saying, or misreading what was written in the books?
The in some localities, the code does require that. Where they require it, obviously you have to follow the code. But the argument is that when you do that, that means that anything that comes in off your antennas, anything that comes in off the antenna, you're going to have some leakage then into the house systems. So we would prefer to avoid that if possible. And by having separate grounds, you do that. The argument that these localities make is they're assuming that it is a commercial setup, like an AM radio station, where you have a 200-foot tower, 120 long radials, and then they would argue that everything should use that you should be using a halo type ground system inside the building, attach it to a bunch of ground rods outside the building, and that the antenna should therefore be attached to the same ground system. For amateurs, that's generally not required, and in the localities where it is, you follow the rule. But if you can avoid it, it's best to be avoided.
Okay, would it make any difference? I'm having a house built that I'm hoping to get into end of this year, beginning of next. And I've had a bunch of stuff done for electrical and whatnot, so that I shouldn't have issues with that, at least for power supply within the shack. But the grounding and stuff, they're kind of leaving that to me. Once they're done, fine, drill the holes and run cable and do whatever you want to do. But the house is set up with the UFR ground. Would that make any difference?
No, that would not. And I know, and there are some of these grounds in which the NEC also requires that if you have buried concrete with metal inside it and stuff like that, or that you have metal that's driven down into the ground as part of the construction, that's supposed to be part of the ground system also. And that's what they're doing in your case. But that would not matter. The main idea is that you want to keep the systems as separate as possible, especially RF systems away from the house ground, because you do not want RF leaking through your house systems. It'll set off your ground circuits. It'll set off your ground fault circuit interrupters, and it'll just make life miserable. You'll end up with the Worked All Appliances Award. That I actually have a Worked All Neighborhood Appliances Award from my early days. We want to avoid that. Where you have to do it, if you can avoid doing it, avoid it. Have your own ground out at the antenna. If you're putting a tower in or a vertical, if you're putting in a dipole, the ground, the RF ground can be closer to the house, but obviously you don't want it right up next to the house. Make all your ground connections as short as you possibly can, and make sure you disconnect everything when you're not operating. You know, and by the way, if you do have ground rods installed as part of your house wiring, ask them to separate them by 20 feet instead of 6.
All right, so far, I'm actually going tomorrow to look and see what they've done with the electrical, but I've only seen one ground rod. But that was the one that they did when they did the slab. So they may add another one, but I will check on that. Thank you. Appreciate it.
Sure, no problem.
Any other questions? Someone else?
I have another question, if you don't mind, Lee.
Go ahead, Glenn. Sure.
Just for general information, if you had lightning rods on your house, although they're probably in most cases going to be lower than what you would have for a HF antenna, would they make any difference? Would it cause any trouble?
Talking about lightning rods on the roof?
Yes.
Oh, okay. No, actually, they're going to be connected. They're going to have connection down through the ground to your ground rods for your house wiring system. And what they'll do is they may prevent a lightning strike, especially an indirect one, from getting worse by discharging stuff directly to ground quickly and not through gear. It won't have any effect on any outdoor antennas. An indoor antenna, I'll be honest, I don't know. It depends. If you have an indoor antenna and you have a whole bunch of conductors running next to that antenna, it will affect its operation.
Okay. Yeah, it was just something else I thought of, and I was just, while we're talking about it, I figured I would just bring it up. And if you were at a 2-story or a 3-story home and you still had a high HF antenna, it could still change the dynamics of that as well, right? Correct?
It could, but the main thing to think about is this: the further you get the antenna away from the house, the less effect any wiring in the house, whether it be lightning rods and stuff like that, static in nature, or any of the AC current, the less it's going to affect the antenna and vice versa. Again, it comes back to Frank's question: how much separation do you want? The question is the answer is as much as is reasonably possible. In the locales that require all the grounds to be connected together, that can be a problem for you in terms of both safety and performance. Definitely in performance, because you might have a lot more AC noise in your line. There are times when a ground is not your best friend, and when it can induce noise into your receiving system, that's one of the worst ones.
Okay, and now, just for instance, say you lived in a low-lying area where you would be putting ground rods into the ground, where the ground, say 3 feet or lower, holds a lot of moisture. Like say you're on the edge of or near a pond or a retention pond or a lake. How would that affect your grounds for your antenna?
Well, the moisture is actually a good thing from a standpoint of ground loss on systems, because it means that if you have moist soil or soil that's highly conductive, your ground resistance is lower, so your ground loss for a vertical system is lower. However, it also means that you can run into trouble meeting the electrical code, and that you may have to have more of a specialized grounding system placed in for the house wiring. It won't change your wiring for the antenna as much as it could the house wiring, because they also look at that. In other words, the ground not only has to be present, it has to be built a certain way to stay there.
Okay. All right. Yeah, that was just a few things that came into my mind. So again, appreciate the info.
Sure.
All right. Thank you, Glenn. And any other questions for Lee before we end?
Lee? Yeah,
Yo.
KC460 here. Just 1 week ago, I took a near hit there. The lightning came probably through my TV antenna, wiped out the TV, did the computer that was connected to it, and came into the shack and wiped out my 16-port Ethernet switch. I feel fortunate. I didn't have any of my gear hooked up. It was too early before any of the nets, so none of my amateur stuff. But I did lose the TV and the computer attached to it and the Ethernet switch. And I'm looking at finding a lightning arrestor for my TV antenna now.
And they do make them, and they're about $30. And you will do this the same way you would do your amateur equipment. You would hook it in line with a coax, and you would put a ground rod for it, an 8-foot ground rod, and then you try to keep the lead between the arrestor and the ground rod as short as possible. Use as large a wire as reasonably possible. At least a number 10, preferably a number 8 or number 6.
Yeah, okay. I agree there. It's and I've got to do some improvement on my my RF ground system here. I did lose a capacitor in the top of my Titan antenna, vertical antenna there earlier this year. Had another nearby lightning strike and it took out the capacitor, but nothing got into the house there. Thank you for your talk this evening.
Yeah, it's kind of a mundane subject for a lot of people, but it's yet so important because it's not just a matter of losing gear if and when you get hit. It's a matter of that you can be hurt or even killed if you happen to be in the wrong place at the wrong time. We want everybody to be safe.
All right, Bob. Good proof that not a matter of when or if it'll happen, is when it's going to happen. So, anybody else question for Lee before we end our session tonight?